Morning. So in this lecture video, I'm going to explain module 5, that is application of digital circuits. Application of digital circuits. Under that, I'm going to explain design of sequence detector. Design of sequence detector. So sequence detector means it is a circuit which detects the sequence. See, this is the model of sequence detector. I mean, it is a logic circuit. It has input X and output Z. So through input X, it is keep receiving the string of zeros and ones. Whenever the prescribed sequence is detected, Z output will be 1. Until that, output is a 0. That means circuit will examine the string of zeros and ones applied to X and generation output Z only when the prescribed input sequences occurs. So it is called sequence detector, the circuit which detects the prescribed sequence and then makes output 1. So here assume input X changes in between the clock pulses. That means change in input is synchronized with the clock pulses, since we are going to design a sequential circuit. So changes in input is synchronized with the clock pulses. Let's have an example. Design the circuit so that any input sequence ending in 101 will produce an output z is equal to 1, coincident with the last one, and circuit does not reset when output 1 occurs. That means it is required to design a circuit to detect the sequence 101, and output z will be 1, and that is coincident with the last one. Let's have a typical sequence, input and output sequence. See, yeah, observe here. Initially x is equal to 0, so z is equal to 0. Again 0, a 0, 1, a 0, and 0, sorry, again 1, 0, 1. That time output is 1. See, this is the sequence. This is the sequence ending with 101. So output will be 1. And this output 1 is coincident with the last one. Coincident with the last one. And again if we receive 1, so output is 0 because circuit is not ending with the 101. Correct? So next we receive 0. Output is 0. Again 0, 0, 1, 0, 0, 0, 1, 1. Because see, the circuit is ending with 101. Circuit is ending with 101. Again next we receive 0, again 1, so again output is 1, because the sequence ending with 1. So here observe one point. See, they are told circuit does not reset when output 1 occurs. That means whenever this one occurs, the circuit supposed to reset, but here they specified does not reset. And again whenever this output 1 occurs, circuit does not reset. And see, observe again, in this point output is 1. That means, see, this one will be the last one of the previous sequence, correct? 101 sequence, and this will be the first bit of a next sequence. So one is overlapped, this one is overlapped, so overlapping is allowed. Overlapping is allowed. Clear na? And again, so we receive 0, output is 0, 0, output is 0. It continues like that. So the circuit produces output 1 whenever the sequence 101 is occurs. Clear na? See, let's say our design. See, construction of state diagram also called as state graph. That means, so in a combinational circuit, once we understood the problem statement, we construct the state table, sorry, truth table, and from the truth table expression, and reduce the expression and simply implementation. Correct? But here, once you understood the concept, either you need to construct state table or state diagram. state table or state diagram. So now let's construct the state diagram. So we understood the problem now. So whenever the sequence 101 occurs, we should make output 1 until that output is 0. See, initially start with the reset state S naught, and in state diagram, states are represented by a nodes. Let's say S naught is a node which represents a state S naught. Okay, so I mean this is the first reset state. So we are waiting for the first bit to be received. Either we receive 0 or 1. Suppose if 0 is received, that is not the first bit. That is not the first bit. Our first bit is 1. So circuit stay in S0 since the sequence does not start with the a 0. And that will be indicated as the directed branch. See the arc. You can say this is arc or directed branch. Above that input is 0, output is 0. That means in the graph the label is in the form x bar z, where x before the slash is input and the symbol y after the slash is corresponding to output. So this is input 0, output is 0. Clear now? Suppose if 1 is received, that means the circuit must go to new state. Say S1 to remember that the first bit of a desired sequence is received. Okay. So it will go to say S1 when the input is 1 but still output is 0. Output is 0. Correct now? So now we are in S1. Means what? When in state S1 first bit of the sequence, that is 1, is received and waiting for the second bit to be received. Suppose again here only two possibilities, either we receive 0 or 1. If we receive 0, that is our second bit, no, so it will go to new state S2 to remember that first two bits, the two inputs 1 0 is received, so it will go to S2. Okay, when input is 0 but still output is 0. Okay, so suppose in S1 if we receive 1, what happens? If we receive 1, the received sequence is 1 1. So the new one will be considered as a first one. So if 1 is received, circuit stay in S1 only since the sequence restarted with the new one as the first input of the desired sequence. So that is indicated by an arc S1 to S1 when the input is 1, output is 0. Clear na? So that means if we are in state S0, reset waiting for the first bit. If it is 1, so it will go to S1. So if we are in S1 means first bit is received. Again if it is 1 means it will be there only, that new one will be considered as a first bit. If it is 0, that is our second bit, so it will go to next state, that is S2. Okay. So in S2, we are in S2 means 2 bits of the sequence, that is 1 0 is received, waiting for third bit to be received. The third input is 1. Okay. So if it is 1, if in S2, if we receive 1, sequence is completed. That means if 1 is received, desired sequence is completed, that is 101, and we should make output 1. Now the question is whether it goes to a new state or it should be reset. No, it should not reset, because in the question they have specified when the output is 1, the circuit does not reset. Then whether it goes to a new state or one of the available state. See, when 1 is received, the recent one will be the first bit. The recent one will be considered as a first bit of the sequence. So first bit, that is 1, is received in the state S1. So it will go to S2. The circuit must go to S1. Go to state S1 since circuit is not supposed to reset, and last one in the sequence can be first one in the new sequence. Clear now? So it will go to state S1. See here, label 1 bar 1 means if it is 1, it will go to S1 and output is 1 because desired sequence is detected. So initially here, if it is 1, it will come here, 0, it will go there, again 1, it makes output 1 and it will come to S1. Clear now? Yeah. Suppose in S2, if you receive 0, 0, the circuit must go to reset state because two zeros are received. Correct? So here 0, again 0. Okay, two zeros are received. So two zeros are not part of the desired sequence. That is why it will go to reset state and makes the output 0. Makes the output 0. See, S2 to S0 when the input is 0 and output is a 0. So this is what the procedure to construct the state diagram to detect the sequence 101. Okay. So once the state diagram is constructed, next is to construct the state table. So that I am explaining in next video. Thank you.